Welcome to this tutorial on measurements. I'm Teacher Alton, and it is brought to you courtesy the Math Ministry at www.maths123.org. In Proverbs 5:21, we read, "For the ways of man are before the eyes of the Lord, and he ponders all his paths." So this encourages us to know that God is always looking at us. He's concerned about our well-being, and he's always there should we need him to help us along the way with respect to any problems, especially mathematics. God orders our steps. He ponders all our paths. So let us continue to reach out to God and seek his help. In question 1, we are told that the height of a cylinder is 24 centimeter and the diameter is 18 centimeter. And in part A, we are asked to find the circumference as well as the area of its surface area, the area of its surface. So the formula for circumference, C, is equal to 2 pi radius or pi by diameter. So we're looking at part 1 in A. Okay, so we say you are using pi as 22/7, and we are told that the diameter is 18. And we can get an approximate value for the circumference. Remember, the circumference is the distance around the shape itself. So we are looking at total distance around. Right, so let's use our calculator to work that out. Right, so that circumference will be about 15.6 centimeters. Okay, so when you're looking at the surface area, now they did say it is a hollow cylindrical container, right? So the assumption is there may be all right, so they say it's hollow. So there may be a base. So we need to find this area below here. And depending if they didn't say if it was open, so we'll assume that there's a cover on top here as well. So we need to find basically the area of 3 parts of this cylinder. So we look at this piece here in blue, and then we look at the top and bottom shaded in red. Now, it is useful if we can visualize what will happen if we cut this part straight down and we open out this. What you're really gonna get, you're gonna get a circular piece on top, and you're gonna have a rectangular piece here that you fold to make this curved portion of the shape of the cylinder. And then, of course, you'll have the open portion at the base here, which will be the base as shown in red below here. So we need to find area 1, and area 1 will be the same as area 2 because it's a cylinder. We are assuming that it is covered, as well as area 3, which is a rectangle. So let's see if we can get our dimensions based on what what is given in the question. So 24 centimeters will be here, 24 cm. We are told that the diameter is 18. So this measurement, the width would be 18. The measurement going across here would be 18. From here to here, it will be 18. All right, let's just write it in 18. So we can find the area of that rectangular piece. So let's call it area 3. Area 3 will simply be 24, which is the length, by the width, 24 by 18. So let's call back up that calculator. Right, so 24 by 18. Right, so that'll be 432 square centimeters. 432 centimeters square. Okay. Let's find area 1, which is the same as area 2. Now, the area of a circle is pi by radius square. Now, since the diameter is 18, it means that the radius is 9, because diameter is 2 times radius. So let's use pi as 22/7, and we're multiplying this by radius square, which is 9 square, which will be 81. And let's see our answer here for that base as well as the top. And of course, we're going to adjust our answers accordingly, right? So let's work out that area using the calculator. So it will be 22 divided by 7 multiplied by 81. And we just round it. Right, so it's 254.6. 254.6. So just for convenience sake, let's round it up to 255. So the area here would be 255 centimeters square. Right, and this is what I mean by making adjustments considering the answer. Now, if the assumption is that it is hollow without a cover as well as a base, if it is a hollow cylinder, like a PVC pipe, then the area of the curved surface will only be, right, the area of the curved surface will only be 432 centimeters square. Right. Now, if it is a cylinder with a base, well, I guess we may be able to all right. Now the question did say curved surface, so maybe they just want to restrict our answer to area 3, but I'll just explain so it will add some information if necessary. Okay, so if you have to find the area of a cylinder only with a bottom piece, then you'll have to add the area of this curved surface here, which is the 432, plus one of the areas, which is the 255. Right, so let's see what that gives us. 432 plus 255. So that will be 786 centimeters square. Right. So the curved surface will only be this portion right here. Okay. So as I'm saying, if you are asked to calculate the total surface area and you only have a cylinder with a base without the cover, then in this scenario, the area would be 687 centimeters. And of course, if you had the third scenario where you had the cylinder was in fact covered for example, these tins, then you'll also have to add an additional 255 to that 687. 7 and 5, 12, 8 and 5, 13, 14, 6 and 2, 8, 9. So that'll give us 942 centimeter square. All right, so let's proceed. Part B of the question, let's see what that's asking us to do. Right, so part B of the question, they give us, right. Let's make some room here. All right, so let's see if we can take out some of that writing. Okay, let's just drag across. I'll work it like that. So in part B, they told us 1.4 liters of water is poured into the cylinder. Calculate the 1 decimal place the height of water in the container. All right. So that part of the calculation is already done. Part of it, that is. So let's look at it. So you pour in 1.4 liters. First to begin, your dimensions are in centimeters. So once you calculate in volume, your answer will be in cubic centimeters. Now there is a relationship between liters and cubic centimeters. 1 liter is equal to 1,000 cubic centimeters. So if you have 1.4 liters, it will be 1,000 multiplied by 1.4, which will be 1,400 cubic centimeters. Right, now you have this big container there as shown in the diagram, right? So let's just draw that right here. And you are pouring in 1 point, right? You are pouring in 1.4 liters, which is 1,400 cubic centimeters. Now, in this scenario, the 1,400 cubic centimeters of water is not going to fill the container. The height of this container is 24 centimeters. And the diameter, if you recall, is 18 centimeters. So the question asks us to find the height of the water. So this water, when we pour in, will only reach a height, let's call it h. And we need to find that h. Now the relationship, let's look at the relationship. The relationship between volume, height, and area. So where a cylinder is concerned, the volume is equal to the base area, right? The base area multiplied by the height. Now we have the volume, which is 1,400 cubic centimeter. All right, so let's take out the dimensions here so we won't get confused. We have the volume, which is 1,400. And we did calculate the base area just now. Here it is. Remember the base area was 255. All right, so if you want to be more exact, the answer is really 254.6, 254.57. But let's go with the 255. So the base area is 255, and we need to find the height. So to find the height, you divide both sides by 255. This will cancel here. And the height in centimeters in this case, 1,400 divided by 255. Right, about 5.5 centimeters. Right, so that'll be our answer for part B. Okay, let's go on to question number 2. So you're given a diagram, not drawn to scale, and it's a rectangular base prism. So let's see if we could visualize what's happening in the back there, right? So the back will be sloped somewhat. This piece will come back here, right, to meet it. Right, let's draw that as straight as we can. This piece will come back here to meet it here, and it will come back across here to meet this piece here, right? So if you are asked to find the surface area, we need to find this side piece here, which is the same as this one. So let's call it area 1. Area 1 here will be the same as area 1 on the side here, opposite it. Right, okay, let's call that area 1. The one in front, let's call it area 2, will be the same as the one in the back, right, area 2. Then we have the top piece, which will be area 3. And then we have the bottom piece, which will be area 4. So if we're going to find the surface area, we can do it in stages like that. Now, it's a rectangular base prism, so all the shapes are basically what? Rectangular. Yeah. So let's see if we can put in these dimensions. Let's look at area 1 first. Remember, area 1, there are 2 pieces. Huh? This piece in the back here, area 1 consists of this piece in the back here. Right, area 1. As well as this piece in the front here. So it's supposed to be identical. Area 1 is supposed to be identical. So let's get our measurements. So if we consider the first rectangle for area 1, let's put that one in green. Area 1 will be the length is 10 and the width is 6 right here. So this first area will be 60 centimeters square. Remember, we have 2 of this, huh? Okay. So the total surface area, let's call it A, will be 2 times area 1 because you have 2 parts or 2 surface area called in area 1, and we also have 2 surface areas called in area 2. That's the front and the back. Let's highlight that one in yellow. All right, so let's work out area 2 now. Area 2 will be the one in front coming down here. Right. Now, that is not a rectangle. You realize that is a trapezium. So we need to find out that area. And one in front and one behind. So let's work out area 2. Right. So area of a trapezium, half the sum of the parallel sides, which is 14 and 8, multiplied by the height. On the diagram, the height is 4. Right? So just to be sure, let's double check the formula for area of a trapezium. Let's go to that area of a trapezium. Let's double check that. They call it trapezoids, and I guess in some cases. All right, so there you go. Sum of the parallel sides A plus B divided by 2 multiplied by your perpendicular height. Okay, so we onto something here. Let's see if we can work out that answer. Remember that is area 2. So this will be 14 and 8 is 22, that's 11. Halfway 22 is 11 by 4 is 44 cm square. Right, now remember you have a lot of resources out there. I mean, If by chance you may not um, or recall a formula, type it up, like how I double check my formula for trapezium, and you do your search and you have your answer. You check various sources just to be on the same side. Okay, so we just got out area 2. Now, the top portion of this shape here, this rectangular base prism, is area 3. So we're going to add area 3 here. Let's work out area 3. Area 3 would be, it's rectangular. So this distance here is 8, and the distance going across here is 10. Are you seeing 10 from below here? So it will also be 10 centimeters up here. So area 3 is 8 multiplied by 10, which is 80 centimeters square. And area 4, which is the last piece below the base of the rectangular prism, would be 14 by 10, which is 140. Right, so we have all the information we need to find the surface area here. So it's 2 times area 1, which is 2 by 60, plus 2 times area 2, which is 2 by 44, plus area 3, which is 80, plus area 4, which is 140. And that'll give us the final answer for the surface area of that shape. Right, so it's calculator time. Right, so 2 by 60 is 120. So it's 120 plus 2 by 44 is 88 plus 80 plus 140. 428 centimeters square. .428 centimeters square, right? So that will be our total area A. Great. So we're gonna get some more practice on this as we look at question number 3. So we have a block of metal in its shape as shown. It weighs 200 grams. It's in the form of a cuboid, right? Not drawn to scale. So what we need to do with that question, we need to calculate the surface area. So again, let's go with our practice. So it's always nice to visualize the shape. So we'll have a line coming down here, one going across here to meet it. And then we're gonna have one coming back across here, right? So if we have to find the surface area, let's do it like how we did it again. It will be this area in the back here, which is similar to this area in the back here, similar to this area in the front here, right? So it is exactly the same. So we know it's a cuboid, it's rectangular. So let's find this first area, area 1. So area 1 will be 4 by 5, length by width is 20 centimeters square. Area 2, let's look at the one in the back. Area 2 will be this portion in the back here, right? This portion in the back here, and which is equal or identical to this portion in the front here. That's our area 2. So again, length by width, area 2 will be 6 centimeter across. That's the length. And you see now it's 5 centimeter right here. So area 2 will be 6 by 5, which is 30 centimeters square. top and bottom again. Right, so the third area, seeing that it's a cuboid, we have, right, our third area will be what is on top right here, right? So that's our third area, the top, which is identical to the base down here, right? So that top is identical to the base down there. So let's find that answer for you. Let's call that area 3. All right, so the length is 6 and the width is 4. So that will be 6 by 4, 24. So it's supposed to be a block of gold, so it will be solid. Total surface area will be 2 times area 1 plus 2 times area 2 plus 2 times area 3. Right, so 2 times area 1 is 40. 2 times area 2 is 60. That's 100. And 2 times area 3 is 48. So total area here is 148 centimeter square. Find the volume of the block. Well, volume here is length by width by height. So the length we know is 6, the width is 4, and the height is 5. So this will be 120 centimeter cube. 6 fours at 24 by 5 is 120. Calculate in grams the mass of 1 cubic centimeters of the metal. All right, that's okay. They told us the total mass, which is 120 cubic centimeter, is equivalent to 200 grams. So if you want to find just 1 cubic centimeter, you will divide both sides by 1 cubic centimeter, you divide by 120. And that'll be the weight of 1 cubic centimeter of this metal. So it's going to be, let's work it on the calculator there. Right, let's clear it. 200. Right, 1.67 grams. Great. So question number, that was question number, was that question number 3? Yes, so we on to the last question. That was question number 3. Right, so we on to the last question here. So again, you given a diagram here, and it's supposed to be the garden of Fifi. Determine the perimeter. Well, perimeter is total distance around. So we simply add perimeter P. We simply add 1 and 2 is 3, and 3 is 6, and 5 11, and 2 13, and 3 16. So it's 16 centimeters, 16 meters. 3 and 1 4, and 2 6, and 2 8 8, and 8 16. Calculate the area. Okay, so if we're going to calculate the area, let us divide this into rectangles, right? So I'm just gonna, let's say, draw the first one, first rectangle there. Right, so we can put a line coming down right here. Right, and we're gonna call this first part of the garden area 1. Right, then we're gonna have to cut off a little piece here. Let's call that area 2. Right, from here, let's call that area 2. And finally, we're going to cut a bit, the last rectangle here, which we're going to call area 3. Right, so once we have done that, it makes it much easier for us to work out the total area for this shape, right, of the garden. Right, so we need to just calculate our dimensions correctly. Well, A1 would be 5, which is the length, multiplied by the 3, which is 15 square meters. Right, so area 2, we need to do a little subtraction. You know, from here, let's see if we can work it out. This width here is 1. This total width here is 2. So it means that this one must be 1. Right? And how do we calculate this piece here now? Right, we don't have this distance here. We have this one is 3. We have this one is 3. So this one will be 1. You know that for sure. Because this from here to here is 2. So this will be 1 right here. Right? So we don't need this height here. We know this will be 1. Okay, so this area A2 will be 1 by 1, which is 1 square meter. And we're looking at the part in blue, it's 1 across and 3 up. So A3 will be 1 by 3 meters squared. Total area 15, 16, and 3, 19. So the area of the garden A would be 19 square meters. Great, so that will take us to the end of our tutorial on measurements. Until we meet again, may God continue to bless you.